Welcome to Fun Python Projects. In this video, our focus shifts to to how to make a factorial finder. Of course, if you've done some mathematics, maybe at the undergraduate level, you already probably have an idea what factorial is about. But if it is new to you, no, not a problem. It's a very simple concept. So a factorial is simply a mathematical operation that multiplies a number by all the positive integers less than itself. All positive integers less than itself, represented by an exclamation mark. So when you see an exclamation mark in mathematics, it's not the normal exclamation mark you know in English, most likely. It is this factorial mark. So for a positive integer n, for instance, the factorial is written as n factorial, and that means you have that n times n minus 1 times n minus 2 times all of that until you get to 1. And very interestingly, by definition, 0 factorial is equal to 1. This has a proof. Maybe I'll talk about the proof in a video, in a mathematics video sometime. And when we talk about special functions like gamma functions, beta functions, and so on and so forth. Okay. So for instance, if we have 0 factorial, of course, you know that's 1. 1 factorial is also 1. 2 factorial is 2 times 1, 2. 3 factorial is 3 times 2 times 1, that's 6. 4 factorial is 4 times 3 times 2 times 1, that is 24. 5 factorial is 5 times 4 times 3 times 2 times 1, and that will be 120, and so on. So factorials are widely used in mathematics, especially in combinatorics, probability, and algebra to calculate permutations, combinations, and coefficients in expansions, right? So, I mean, in this case, you are looking at Factorial Finder using Python. So in programming, the Factorial Finder helps to illustrate loops, recursion, and algorithmic thinking, making it a common beginner-friendly project for understanding function design and iteration in Python. Okay, so having understood the background of factorials, so let's see the different possibilities of a factorial finder. First of all, let's look at a basic factorial finder using for loop. Now, under Python basics with EJD, if you check through the playlist, there's a place there where I talked about control flow in Python, and I particularly focused on loops, like where we talked about for and while loops. So basic factorial finder using for loop. So here we have factorial finder using loop, and here we define a function. So we say define the function is named factorial, and it takes the number, the variable, the number you're starting with. Let's put it that way, and then you have this initialization where the result is equal to 1. By the way, don't forget, based on the definition, you are talking about a positive integer. So you're talking about the factorial with positive integer, and then whatever number you take, then you multiply it by a number less than it, and you continue until you get to 1. And whatever you get is your result. So you now say for I in range 1 to n plus 1. So if you are doing 5 factorial, for instance, so it means you're doing from I in range 1 to 6. And of course, that will be 1 to 5 because you don't get to that 6. Then the result will be, so you multiply, whatever you bring, you multiply by this, by the initial one here, and then it will be updated, and then you return the results, right? So imagine that you have 5, like we said. So the first result is 1. That's the starting point. So for 5 now, we say for I in range 1 to 6 now, all right? So you have 1. So you print that result 1. So you come here, that 1. So for I in range, in this place again, so you already have the 1. So you now take that 1. So having taken 1, the next number will be 2 in this range. So you now multiply that 1 by 2. You get 2. The result will be printed as 2. And then you go again. You pick 3. So 3 times the 2 you got, that's 6, and you keep going until you get whatever you need to get. So for example, imagine that this one is requesting you to type in a number. Num is integer, input, enter a number. So you are going to enter an integer, a whole number. That's what this 10 is asking of you. But in 11, you print the factorial of that number, and you now take the factorial of that number. So you see this factorial right here. So this function defines factorial. So factorial of num. So that's factorial num. So whatever you pick, so this one will now run it on this function, and you get your result. So if I run this now, it will ask me to supply a number. Okay, this is the first one running, so that's why it's taking a bit of time. Of course, let's check out zero. We know zero factorial is one, right? So zero factorial is one. So I run it again and I go for one factorial. That's also one. I run it again. I take two factorial. That's two. I run it again. Three factorial. That is six because that's three times two times one. Four factorial. That's four times three times two times one. That's 24. Five factorial. All right. That's 120. 7 factorial, 6 factorial rather, 6 factorial, oh, 6 factorial is already 720. Then 7 factorial will be 5040, 5040. Then we can go for 8 factorial, that's 5040 times 8, that's 40,320. Let's check out 9 factorial, we get 362,880. Then let's stop at 10 factorial. I mean, you can go all the way. 10 factorial. Okay, let me make a bold move. Let me go for 100 factorial. You see, that's a lot. The number is so large. That's 100 factorial. Imagine going to 1,000 factorial. So it's gonna be quite a lot. Okay, so let's move on to another thing. So you can do your factorial using the loop format like that. So you can also, another way to find factorial is using recursion. Recursion is, the number will be reducing until you get to the last. So here we define a function again called factorial, which takes n. So if n is equal to 0 or n is equal to 1, just return 1 because we know 0 factorial or n factorial is 1, right? Or 1 factorial is 1. Else, so this is where the recursion comes in. Else, you now return whatever n you have multiplied by the factorial of n minus 1. Okay, so what this means is that if we take 5 factorial for instance, so of course it's not 0 or 1. So you just go, you say 5 times factorial of 4. So you come to 4 again. Okay? So you come to 4 again, and you have so it's not 0 or 1. So it's now be 4 times factorial of 3, and it keeps going like that until this one can now be until n is equal to 1, where you return 1. At the end of the day, everything will be multiplied together recursively, okay? And then so we can take an example. Of course, again, you can impute number. So if you impute a number here, one thing I did not try before, what if we impute a negative number? What happens? So if I input a negative number, say minus 12, so it tells me that the answer is 1. Now, the reason this is happening is because we set the default result is 1. So it doesn't mean that minus 12 factorial is 1, by the way, but because we set the default to be 1. Let's see what happens here. So if you put in a negative number, say we just want to find minus 2 factorial. So you see, this one gives an error. So it says maximum recursion depth exceeded because you cannot find the the factorial of a negative number in this context, right? So we go again and do the regulars. So 0 factorial, that's 1. Run again. 1 factorial, that's 1. Run again. You have 2 factorial, that's 2. Run again. 3 factorial is 6. Run again. 4 factorial is 24. Run again. 5 factorial, like we knew, is 120. 7 factorial, is this. Let's go for 50 factorial. Let's see what happens at 50 factorial. Okay, so the number can still be seen on one screen. So you can see it's that very long number. So we can also do Factorial Finder using math module. This is about the easiest way to do factorial because the factorial function is already inbuilt into the math module. So, and the math module is an inbuilt Python library inside. It's an inbuilt Python library, so to speak. So you don't need to import it. You don't need to install it. You don't need to import it. I mean, okay, you only need to import it because it's already inbuilt in Python, right? So here, this is about the easiest. You have Factorial Finder using math module. So you just import the math module, math. Then you take a number as usual, like we've been doing. Then you can now print the factorial of num is math.factorial. So what is doing the real job is this. So from this math, now it means there's a function from this math module, there's a function called factorial. All right. And whatever number you supply, it will take the number and output the result. So here, let's start with something negative. Because normally, we're not meant to look for factorial of negative number. So minus 4. So this one tells us factorial not defined for negative values. Clearly. All right. So not defined for negative values. So we go for 0. We know that's 1. We go for 1. We know that's also 1. We go for 2. That's 2. We go for 3. That's 6. We go for 4. That's 24. We go for 5. 5, that's 120. We go for 6, that's this. So let's do 60 now. Let me just go crazy. I mean, we pick a big number, 60. So you see how long that goes. Okay, it looks like 50 can still be accommodated within the scope we have. Okay, we have to still shrink it. So that's how that goes. So you can see the easiest of them all is this math module thing. Then we have Factorial Finder with error handling. Now you remember, okay, here, when we did negative number here, we got -1. When we did it here, we got 1, which is not true, which is not correct. But because we said the result will be 1 by default. All right. I think there's another one that also told us so here, so in these two cases, we had errors. But what if you want to handle the errors without it giving you with error handling? You know, error handling is making sure that if there's going to be an error, you don't get the error, but you just get an information that is an error. So see what happens there. So we are using the math module that we just used up there. So define factorial underscore finder, try num. So input the number, enter a non-negative integer. Okay, very important. That's a positive integer. So if num is less than 0, you know what to tell you? Factorial is not defined for negative numbers. Straight up. That was what we saw in the math module. Else, print the factorial of num is math.factorial num. So if it is 0 upwards, then it will give you the factorial. Then you have an exception value error. Print. Please enter a valid integer. So if you don't enter the right thing, it tells you to enter a valid integer. So you can just call the factorial finder here. So we run this, and then it gives you, so for 2, so we have say we need 10 factorial. We have this. All right. Another thing you can do is you can just fix the number up from here. So instead of having to, so oh, what's happening here? Factorial finder takes 0 position argument, but 1 was given. Okay, so we don't need this. All right, so we do this. So this is the only prompt, and then every other thing runs. So let's do 11. So this is what we get for 11, and so on and so forth. Let me do a big number. Let me say 45. Okay, 45 factorial. So it's this long number. All right. So with that, let's come to the end of this video. Very interesting video about looking for factorials. And factorials can be pretty useful. When you're uh, in the trial, feel very free to let me know. If you have subscribed already, I thank you so much. If you haven't subscribed, of course, you want to go ahead and subscribe, and of course, hit the notification bell so you can always get alerted each time a new video is released, right? Having done that, you can take it a step further. You can become a member of the channel by clicking on join, and that gives you some special privileges. And that includes having a one-on-one virtual hangout with me, to discuss anything I discuss on this channel, maybe maths or data science, data analysis, scholarships, whatever. So we can have that. So you become a member and enjoy that. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing Python right. Bye.